In this tutorial, we're going to analyze the motion of blocks of wood placed on top of each other on a frictionless surface at which an applied force is exerted on either one of them. Hello, this is Physics is Easy with Mr. Jesse. A block of mass m rides on top of a second block of mass capital M. Consider mu as the coefficient of static friction on the surface between the two blocks. Give your answers in terms of small m, capital M, mu, and acceleration due to gravity g. The figure below shows the bottom block pulled horizontally by a force F on a frictionless surface, and the block M does not slip. So take note, it is actually the surface at which the capital M is in contact with that is frictionless, so this surface right here, but the surface at which the small m and the big M are in contact is not frictionless, and that is the reason why we have this coefficient of static friction. So again, this coefficient of static friction is for the surface between the two blocks. Draw the free body diagram for each block. This is the first question. So we look at the smaller block, small m. The forces acting on it would be the following. So first we have the force of gravity on the small block. So that is going to be an arrow directed down. So we would call this weight of the smaller block m. And there is a force, an upward force exerted by the bigger block on the smaller block, and we could call that normal force, and that is actually an upward force, Fn. So the fact that the smaller block is in contact with the surface of the bigger block, then we will have normal force. Now, as the bigger block is being pulled towards the right, then the smaller block has the tendency to move towards the right, but as it does, friction between the surfaces of the bigger block and the smaller block would take into place, and that friction right there is opposite to the possible motion of the smaller block, so it would be directed here, and we would call that friction. On the other hand, for the bigger block, capital M, the forces acting on it would be the following. So we already have the applied force. So we have the applied force here. That is our applied force. And it is actually this force right there. But since we're drawing free body diagram, so we start from the center of that object, or we represent the object as the dot. Another force acting on it would be the force of gravity, but since this mass right here is actually on top of the bigger block of wood, it would add up to the force of gravity. So as a matter of fact, the downward force, which is this one, is just equal to the weight of the bigger block plus the weight of the smaller block. So if we are going to rewrite this, it's just going to be capital mg plus small mg. And we also have normal force since the bigger block of wood is in contact with the ground, so there is a normal force acting on it, and we would call that Fn of the bigger block M. Now, as the bigger block is being pulled towards the right because of this force right here, it will the friction that exists between the smaller block and the bigger block would now take into place, and for that reason there is actually a friction headed in this direction. So that is friction right there, and that friction, this friction is actually the same as this friction. So again, this friction here is not due to the ground here, but due to the fact that a smaller block and bigger block are in contact with each other. So their surfaces are in contact, which would bring about friction. Now, the most common source of error for this particular question is the identification of the friction that exists between the two blocks. So failing to give importance or failing to recognize this friction right here on both masses could actually lead to erroneous calculations. So remember that friction does not only exist between the floor and the object, but it could also exist between the surfaces of blocks that are placed on top of each other, just like in this example. Second question, find the maximum acceleration of the blocks. Remember that we had to give our answers in terms of small m, capital M, coefficient of friction, and the acceleration due to gravity. Now, since the two objects are actually considered as one system and they will be moving simultaneously or at the same time, then it is safe to say that the acceleration of m, or the magnitude of the acceleration of the smaller block, would be the same as the acceleration of the bigger block. And if we are going to look into the free body diagram of the smaller block rather, the weight of the smaller block is actually equal to the upward force exerted by the bigger block on the smaller block, or this normal force here. So in fact, they cancel out each other. So the only force acting on it would be the force of gravity. I mean, the force that acts on it that causes an effective motion is the friction force. Okay, so if we are going to start with Newton's second law, so that's F net is equal to ma, then therefore we could say that F net, which is the only force that causes or that results to an effective motion, is equal to friction, and that is equal to m, or the mass of the smaller block, multiplied by its acceleration. Now, since again we are only going to express acceleration in terms of the following symbols, so friction right here is equal to the coefficient of friction multiplied by the normal force, or Fn, or simply n, and that is equal to m times a. And our normal force is just equal to, in this case, the weight of the smaller block m. So we will say mg is equal to ma. Manipulating this equation, we could divide both sides by, we could divide this by m, so that we will have a, we cancel this out, we will have a is equal to the coefficient of friction multiplied by acceleration due to gravity. So this is our maximum acceleration. And this acceleration is the same for both blocks, the big block and the smaller block. Third question. What is the maximum force that can be applied without causing slipping? We still had to give our answers in terms of the following symbols. Right, let us analyze the question first. What is the maximum force? So this force that we're talking about is actually this force here. This is the applied force, or the capital F. And that can be applied, so that's the capital F, that can be applied without causing slipping, and this slipping means without causing the system to move. So it's related to movement without causing slipping. Okay, so therefore we would be looking into Newton's second law, and that's going to be F net is equal to ma, but since the object that we are talking about here is the bigger block, so we will have it as capital ma. And the forces that we will be considering are the forces that are on the axis, are on the axis at which your acceleration would possibly take place, and in this case it is actually on the horizontal axis. So this means the vertical component of the forces acting on the bigger block cancels out each other. They don't really have bearing into the motion of the object. So our F net would just be the applied force minus friction, since it is in the opposite direction, and that is equal to capital MA. Now let us expand this further. So the applied force, capital F, minus friction is just mu multiplied by the normal force, is equal to MA. Now, very important thing to take note. The normal force that we are talking about here is the normal force that is associated with the friction. So therefore, this is the normal force that concerns both masses that are in contact with each other. And in this case, this normal force is the same as this normal force. This is the normal force that is associated with the friction. Because again, this is the normal force, or the force that the block of wood, the lower block of wood, exerts on the block on the upper block of wood. Okay, so now we will have the equation. Let us expand this further. We will then have F is equal to minus mu. That normal force is equal to mg, the weight of the smaller object or the smaller mass, and that is equal to MA. Again, the normal force here, I could not stress this more. The normal force here is the force associated with the friction, and this is that normal force. That normal force. All right. Let us continue manipulating this equation. So we will have F is equal to capital MA plus mu mg. Now we have found out our acceleration in the previous problem, in the previous question. So we substitute it here in this equation, since we only have to express our answers in the following terms. So our acceleration was mu g plus mu mg, and this is equal to our maximum force that can be applied without causing slipping or movement. Part B. The force is now applied on the top block M as shown in the figure below. What is the maximum acceleration of the system before slipping? Again, when we say slipping, before M or the small block separates with the bigger block. Give your answer in terms of the following symbols. Okay, so here it is very important that we will be able to analyze the free body diagram of each block. So for the small m, the forces acting on it would be the following. So we have the applied force, F. We have friction directed to the right. So as we applied force, there will be friction right there. And then we have the normal force, which is the upward force exerted by the bigger block on the smaller block. And we also have the weight of the smaller block. Now for the capital M, or for the bigger block, we have the following. So since the smaller block is on top of it, so the weight of it would just be equal to the sum of their weight, or this downward force would just be equal to the sum of their weight. So that's mg, capital M plus small mg. We have the normal force exerted on the system, so we'll call it Fn, but this one is m plus n, rather small m plus capital M. We have friction. So as we exert the force, as we exert this force on the bigger block, on the smaller block, the bigger block comes along with it, and that is because of friction. Alright, so we can easily find the maximum acceleration by looking at the free body diagram of the bigger block of wood. So The only force that causes it to move would actually be friction, since the vertical component does not have a bearing on the motion of this block of wood right here, then the bigger block of wood rather. So we will have F net is equal to capital M A, and our F net in this case is just friction, so that is equal to mass times the acceleration of the system. So remember that the acceleration here, the acceleration rather of the bigger block of wood should also be the same as the acceleration of the smaller block of wood, because they're moving together as one. And here, our friction once again is just mu multiplied by the normal force with which the friction is associated, multiplied by M times A. Again, this normal force is the normal force that is associated with friction, and that is equal to the mass of the smaller object multiplied by acceleration due to gravity, or equal to the weight of the smaller object. Once again, let me stress this out. The normal force is the force exerted by the surface where friction occurs, or is where friction exists, and in this case it is this surface right here, not here, because this is actually frictionless. Okay, and that is equal to capital M A. Oops, I can't erase this. Let me check if I could erase this. Alright, never mind. So let me just rewrite that here. Let me rewrite that part here. So we have mu, we have mu mg is equal to capital M A. Now I'll divide both sides by capital M. I'll divide that by capital M. So my acceleration is equal to mu mg all over capital M. And this is my maximum acceleration if the force is applied on the smaller block that is placed on top of the bigger block. The maximum acceleration of the system before the two blocks would slip from each other. Next, question 2 of part B. What is the maximum force that can be exerted on the block without causing it to slip? So again, the maximum force, which is actually this F here, that we could exert on the block without causing the block to move with respect to each other. So if they move, they have to move as one, so without causing it to slip. Okay. So we are now going to look at the free body diagram of the smaller block, because this is where we could find the applied force. So let's start with F net. So that's F net is equal to M, that's the smaller block, multiplied by the acceleration. Now this acceleration again is due to the fact that they are moving as one. So, and it is the acceleration that we have found earlier. So now our F net would be equal to the applied force multiplied by, minus friction that is directed on the opposite direction here. Right, that's why we have negative, is equal to mass times acceleration, small m. Now we have expanding this, we have F is equal to, our friction is mu multiplied by the normal force is equal to MA. Again, this normal force right here is the normal force that is associated with the friction. So in fact, this is the normal force exerted by the surface at which friction is existing, and in that case it is this surface right here, that surface. So in fact, that normal force is this normal force here, which is equal to the weight of the object in terms of magnitude. That is our Fn. Okay, substituting that in this equation, we will have F minus mu, normal force is mg, is equal to m multiplied by the acceleration. Manipulating this further, we will have F is equal to ma minus mu mg. And since we have to express our answer in terms of the following symbols, so let's expand acceleration since we have solved for acceleration earlier, and that is mu mg over m minus mu mg. And oh, sorry, this should be plus right here, pardon me, this should be plus because we're moving this one to the other side equation, and this should also be a plus. And this in fact is our maximum force that we could apply into the block without causing the two blocks of wood to slip away from each other. What would happen to the blocks if the applied force is greater than that found in part 2? Tick all the correct statements below. So the force that we're talking about is this force here that is being exerted on the smaller block. So what would happen if this force here is much greater compared to the force that we have found in part B? So of course, the reason why these two blocks stick together or move as one is because of static friction. So if our force would be able to overcome that static friction, then therefore friction will now be kinetic, and at this point the object would start to move with respect to each other, or they would start to slip. Now, if the force was exerted on the upper block, then therefore this would never be possible. Block M would slide off the back end of block M, so it is never possible. However, if the force was exerted on the lower block, then yes, this could be considered correct. Alright. Both blocks will continue to accelerate at the same rate, so this is wrong because again they would now be moving separately. They will be moving in the opposite directions as a matter of fact, so they will no longer continue to accelerate at the same rate. They could only continue to accelerate at the same rate if they move as one and considered as an entire system. And that concludes this tutorial. Once again, always remember, physics is easy with Mr. Jesse.